Iowa soils, rich soils, are incredibly important for Iowa for economic purposes, as well as global food security. The challenge we have is that Iowa soils are eroding 10 times faster than they're being renewed. This has negative economic as well as environmental implications, and to put it in perspective, for each pound of corn grain that we remove from Iowa fields, we are eroding more than 1 pound of soil. To address this issue, the first step is identifying spatial and temporal variations associated with soil losses in the state. In reality, the Daily Erosion Project, which we've developed, covers Iowa and sections of multiple Midwestern states. The first step in making this happen is to identify a process-based soil erosion model that we can use to estimate soil erosion on over 220,000 hill slopes that are randomly selected, spatially distributed, and georeferenced in the state of Iowa. In making estimates on each of those separate hill slopes, a big challenge comes in. How do you furnish the model with the inputs necessary when we're sitting here in Ames, Iowa? Remote sensing is the key. For every 1 square kilometer in the state, we have a precipitation estimate every 2 minutes. We use LiDAR elevations to get slope and slope links. We use electronic soils databases to get the soils, and because cropping practices influence soil erosion, we need to know the field boundaries, all field boundaries in the state, and what crops and what tillage practices are used inside each one of those fields. We use Landsat and other electronic databases for that. We run the model on each one of the hill slopes, which takes about 4 hours every day, and with that we get crop growth and we get hill slope water runoff estimates and soil erosion estimates. We scale the estimates to the HUC 12, that's hydrologic unit code. They're small watersheds in Iowa, and then we post those estimates every day on the web for public use and consumption. Now the next slide I'll show you is the result of 4 years out of the last 9 that we've run. You will see color-coded maps with the color codes. The darker the code, the greater is the soil erosion estimate. We've added the daily erosion rates through the year, so each one of these maps correspond to a given year. The upper left-hand map is that for 2008, 2009, to the right, 2010, and 2012. So what have we learned? We've learned a lot of things, but just 2 or 3 real simple ones here. The patterns of soil erosion are quite consistent even across years. If you look at some of the heaviest erosion rates here in 2010, the color ramp indicates we have erosion rates in some areas over 40 tons per acre in that given year. Our next steps. What happens? This is sheet and rill erosion off of hill slopes. That encompasses about, on average, about 2/3 of the total soil erosion loss. We're looking for help. Anyone interested in joining the DEP team that would allow us to estimate gully erosion on the base of these hills, you're more than welcome to join. Thank you.